Hi folks, so this is question 5. So estimate the value of g of 1.5. So you have to estimate. So if we go to 1.5 and look where it meets the graph. So 1.5 is around there. So if you go straight up, then it's up to here. So it's at that line. So it's 2, I would say. It says show the work on the graph as well, so you actually have to draw that line that I drew in. Estimate the value of x for which g of x is minus 6. So where is minus 6? So we have to look at minus 6 on the y-axis then. So it's down here. So if we go across from there, yeah, so it's over here. So it's looks about halfway through that box. So we could say minus 2.75. And you need to draw a line across there as well. Tick 1 to show how many real roots the function g of x has in its domain. Give a reason for your answer. So the number of real roots. So we just have to look for places, times or places it crosses the x-axis. So it only crosses the x-axis once here. So therefore 1 is our answer. So it crosses the x-axis once. From the graph, estimate the coordinates of the local maximum point and the local minimum point. So yeah, as accurately as possible. So there'll be a bit of a tolerance here for if you don't get it perfect. So the local maximum anyway is here, I'd say. So it's minus 1.5 minus 1. Then the local minimum point is where it bends down and goes up again. So it's here. So it's a half minus 3.1, I'd say. So something like that. Okay, find h dash of x. So you just have to differentiate the function. So you'll just multiply by the power. So it'll be 3x and then power goes down to 2. 2 times 2 then is 4 and reduce down the power to 1. And then it'll just be a minus 1. Okay, so 1 times minus 1 and power goes to 0. Find the equation of the tangent to h of x at the point. Okay, so first thing we need is we need the slope of the tangent, and we get that from dy dx. So we already know what the derivative is. So h dash x is equal to 3x squared plus 4x minus 1. Now it's at the point 2, 6, so 2 is our x coordinate, so we can put in a 2 instead. So we get 12 plus 8, which is 20, take away 1 is 19. So we get 19, so that's the slope of the tangent, so we just have to use the equation of the line formula then. So y minus and 6 is equal to 19 times x minus 2. So y minus 6 is equal to 19x minus 38. Bring the 6 across, you get minus 32. You get minus 19x, just rearranging now. So something like that. So that's it. That's all for question 4.